Alright, so the point of this lab is to analyze the system, spring mass system, using both the momentum principle and the energy principle. So, the first thing that we were supposed to do is determine the period for the y direction and the x direction. Well, you did this, I did this by using tracker. When you go in here, you can see the oscillation time period, and they look almost identical, which they were, essentially. What I got was, when I looked at the time period, the y direction was about 1.329 seconds, and the x direction was 1.529 seconds. And these are pretty similar results. This makes sense because the time period, W equals 2 pi over T, which determines the time period, and W is equal to the square root of Ks over M. And since both the spring force and the mass for both of them are the same, it makes sense that they have the same oscillation time period. The next thing that was asked, here we go, is we're supposed to use a new choice of the system to determine the work done by the surrounding. Well, okay, so I determined that the whole entire system, that the system was consisted of the spring, the mass, and the earth. So, because of this, try to readjust it. Sorry about this. There we go. Okay. So, now I decided that the system consisted of the spring, the mass, and the earth. So the system is essentially the universe. Well, since the change in energy of the system is equal to the work of the surrounding, I said that the change in energy of all those components is equal to work. Well, since the system is the whole entire universe, or the only variables that are offered, that means the work of the surrounding is equal to 0. So we have delta S plus delta G plus the change in kinetic energy is all equal to 0. So when I plugged this into my Python simulation, that's what I got for my value of work. So that means I know I was doing it correctly. Okay. So the next thing that they ask is, how does the changing the location of the mass affect the changes in energy? Well, here I can show you right here. Here is the mass at the initial y position. Since the mass initially was only brought up a little bit, raised a little bit, the MGH, mass times gravity times height, is lower, since the delta y is a lot smaller. But if you change this to 0, then that means that it's all the way up there. The height is the delta y, or the change in height, is a lot greater, which means a greater gravitational potential energy, which coincides with the kinetic energy and the potential energy of the spring, because they all have to balance out and equal to 0. So here's what it looks like. My bad. I'll run the code for you right now. This is the code I used. If you set the ball position equal to 0, with only the x component right there, here's all the stuff. Here's all the energy rules. And you can run it. So, boom. That's what it looks like. And as you can see, it's the same as before, the energy, but this is a little bit larger. I guess a little bit different, but, and alright, that pretty much sums up. See, there we go, and eventually the work is equal to 0, so boom. That pretty much sums up Lab 9, Part 1. Thank you guys very much. I'm sorry that it was a little bit fuzzy. See you guys soon.